All right, so again, a system of equations involves two equations with two variables. The solution is an ordered pair, x comma y, which is a point. So let's look at example 1. It says, given the system of equations, determine whether 4 comma 1 is a solution. So, Jacob, what might we do if you want to figure out if 4 comma 1 is a solution to the system? Perfect. Exactly. What we're going to do is we're going to plug in that the 4 is the x, the 1 is the y. So you're going to take the first equation and we're going to plug it in and go 4 plus 2 times 1. And I like to put a little question mark here. And the reason why I like to put a little question mark is I don't know yet. So 4 plus 2 is 6, so this is a yes. That worked. And now we're going to do 4 minus 1 equals 3. Well, 3 equals 3 is a yes. So determine whether it's a solution. You have to get 2 yeses in order for it to be yes to the system. All right, I'm going to pause and I want you to try example 2 on your own. Given this system, determine whether negative 1 comma 2 is a solution. Now, if you get a no on the first one, you don't need to waste your time. You just stop. But if you're asked this on the next quiz or test, you need to show that you plugged it into each one and whether you got yes or no. So it works in the first one. So negative 3 minus 4, that's a no. So after you say your yes and your no, off to your side or in an answer blank, you're going to say no, because it has to work in both. Any questions on example 1 or 2? All right, to solve a system of equations, the first method we're going to look at today is graphing. Tomorrow we're going to do substitution and elimination. So the steps to solve the system by graphing. So I put the steps in. So if you ever forget when you're doing homework or a review for a quiz or a test, I want you to look through your notes before you ask somebody to help you. So step 1. Solve each equation for y equals mx plus b. Graph each equation. The solution to the system is a point of intersection. So let me pause and I want you to graph each one on the same coordinate grid. And see if you can estimate the solution. The solution is where they intersect, and where they intersect is a point. Okay, so y equals 3x minus 3. You know how to graph that. We just reviewed it in our warm-up today. You guys see that one hit nicely. Are you guys getting 2, 3?
Yep. Yeah.
All right, now watch this. You can actually check it. If I do 3 equals 3 times 2 minus 3, that works in the first one, right? If I take this and I plug it in the first one, 3 is equal to 6 minus 3. That's a yes. And then I can go check it in the second one. 3 equals negative 1/2 times 2 plus 4. That's negative 1. Negative 1/2 times 2 is negative 1 plus 4. 3 equals 3. So this, I can see it graphically, but I can check it algebraically. All right, when you're ready, flip the page. And I want you to graph this. So you can either do the intercept method, you know, where we make the table for each and plot it, or you can put them in y equals mx plus b form. All right, so I'll give you a head start on me. So I'm going to take the first equation and put it in y equals mx plus b form. So I'm getting y equals negative 2x minus 6. So you go down to negative 6. And then the slope is down to right 1, down to right 1. Well, if it's down to right 1, you can go back and go up to left 1, up to left 1. And then if I take the second equation and I add 4x and then divide by 2, I get y equals 2x plus 2. And then I go up to right 1, up to right 1. Then I can go the other way. Ding, ding, ding. I have a winner. Where did it intersect? Anybody got it? Julia, what'd you get? Yeah, negative 2, negative 2. And you can always check it in the equations. All right, questions on those two? All right, here's an exploration. A system of linear equations consists of 2 lines. Let's look at the possibilities. The first possibility is the 2 lines can intersect. Now, they can intersect perpendicular or slanted. When they do this, there's one solution. The second possibility is the 2 lines are parallel and there's no solution. Is the 2 lines could in fact be the same, and the one is right on top of the other one. We call that the lines coincide. It's really the same line, but it's called that the 2 lines coincide. There's infinitely many solutions. You may not use the capital R. Does anybody know why the capital R doesn't work here? Why is all real numbers not the same as infinitely many? Yeah.
Is it because when they coincide, it's only a certain set of numbers they're going for?
Exactly. They're only the points on the line. So it's not all real numbers. So don't ever use the capital R here. That would not be appropriate. Alright, so these are your options. Either the two lines intersect at a point, which that's what we've seen so far. We could have parallel lines. Now, how would you know from an equation that two lines are parallel? Yeah, Julia? They have the same slope but different y-intercepts, right? And then if there's infinitely many, they would, when you solved it for y equals mx plus b, they're going to be exactly the same lines. All right, so in example 5, I want you to go ahead and put both of these in y equals mx plus b form, and then graph it. So again, solve each one for y equals mx plus b. So you can see a beautiful connection to why I kept emphasizing solve for y, solve for y. We're using that skill. So the first equation, when I solved for y, I'm getting y equals negative 3/2 x plus 5. With my second equation, when I subtract 3x and divide by 2, I'm getting y equals negative 3/2 x plus 1. So right here, without even graphing, can you tell by looking at the equation, they're parallel because they have the same slope but different y-intercepts. So if they're parallel, that means there's no solution. But let's go ahead and graph it just so we can see it. So if I go up to 5, 1, 2, 3, 4, 5, and I go down 3, right 2, down 3, right 2, and then I plot a y-intercept of 1, and I go down 2, right 2, you can see they're parallel. So the solution to a system of equations is an ordered pair. All right, in example 6, without graphing, determine whether the system has one solution, no solution, or infinitely many solutions. So let's write ourselves a note to help us in case we ever forget. And here's the note. Solve for y and check the slopes and the b value. If the slopes are different, they're going to intersect. Okay, let me say that again. If the slopes are different, the lines are going to intersect. If the slopes are the same, you need to check the b values. If the slope and the b values are the same, it's the same line, infinitely many solutions. If they have the same slope but different b values, they're parallel, which means no solution. All right, so I'm gonna pause, and I want you to try A and B, and then go ahead and go down to the self-check as well. When we're done with the notes, we're going to do an exit ticket where you're not going to talk to anybody. I'm going to do a check. What do you know? You're going to turn it in. It's formative, so I'm going to put a grade on it, but it's not going to count in the grade book. It will be formative, but I just want to do a check. This should be review from Algebra 1. So what we're going to be doing in this unit is we're going to start with what we know, and then we're going to take it up to the Algebra 2 level and look at a 3x3 system. That's an Algebra 2 level. All right, letter A, did you guys get different slopes? So what does that mean? How many solutions? One, okay? Letter B, I solved the first one for you, so the second one I'm going to subtract 6x, and I'm going to divide by -3, and I'm getting y equals 2x minus 3. Uh-oh, those are the exact same lines, right? Say it again.
Infinite solutions.
Yeah, so we're going to say infinitely many solutions. And you are welcome to abbreviate. All right, now go ahead and do the self-check, and I put the answers right here. Do you see where the answers are? So I'm going to pause my video because the answers are there. And I